In this question, it is given that a satellite is launched into a circular orbit of radius r around the Earth, while a second satellite is launched into an orbit of radius 1.02 r. The percentage difference in time period is. So we know the relation between time period and radius, that is t square is directly proportional to r cube. So RM is to find out the percentage difference in time period. So we know that we can write this t is directly proportional to r raised to 3 by 2. Or we can write the percentage change in time period is equal to nothing but 3 by 2 times of percentage change in r. So first we can observe what about the percentage change in radius over here. So percentage change in radius is equal to nothing but final radius, that is 1.02 r, minus initial radius, which is r, divided by initial radius, which is r, into 100. So we can cancel this r. So it's going to be 1.02 minus 1 into 100, which is equal to 0.02 into 100, which is equal to nothing but 2%. Now we can just substitute this value over here. So according to this equation, that is percentage change in t is equal to, we can take it as 3 by 2 times of percentage change in r, which is 2%. So we can write this is going to increase by 3%.